Okay, so for this one, when you guys put it into your calculator, did you guys sketch this graph? All right, so this is the second graph, right? That's what it should look like. I'm just gonna try to put that there. Okay, so for the first graph, we should have x minus 2 cubed, yeah, plus 3. That's what it should look like. All right, so is it continuous, which means, can I draw a line without picking up my pencil? Yes, it is continuous. Is it one-to-one, which means I can draw straight lines across and only touch it one time? Yes, it is continuous. Or sorry, it is one-to-one. All right, what do you guys get for the second one? Is it continuous? Yeah, it is. Is it one-to-one? No, because if I draw vertical or horizontal lines, I'm touching in more than one place. So it does not fit the one-to-one. All right, so finding the domain and the range. The domain is the x value of the function. You look left to right. Polynomials have domains of negative infinity to positive infinity. I keep telling you guys, if you have a domain for this unit, it is going to be negative infinity to positive infinity. Your range is the y value of the function. And you look from bottom to top. You guys know we're testing on Friday, right? All right, so you're only taking the test on Friday. There are no retakes. There are no test corrections. If you want to earn extra points, you need to participate in a review day next class. All right, what's my domain here? Please don't get this wrong. Negative infinity to positive infinity. Good. You should always get at least 1 point on the test. Right? That's yours. 1 point. All right, my range is from bottom to top. Because I have an arrow here going to the bottom, that means I'm going towards negative infinity. What's my range? From negative infinity up to what? 3. Nope. Keep going. Look at this whole graph. It's going up to the positive infinity. So Carla, we aren't stopping there because our graph keeps going up higher than that. Okay. My real zeros means where do I cross the x-axis? All right, there are 3 of them. Jordan, what are they? Negative 2, okay.
1.
Positive 1 and
6.
6. Good. If you want to write these as points, you are allowed to do that. Your points will look like this. Negative 2, 0, 1, 0, 6, 0. Tomato, tomato, they're both the same thing. If you just write numbers, like here, then you have to write x equals, so I know that you know what you're talking about. Alright? Look at number 3. Sorry, number 2 is taking this up. Alright, my domain is going to be negative infinity to positive infinity. It keeps going left to right. So my range is from bottom to top, okay? If I start from the bottom, looking at your y values, I'm starting where? Negative 9, and I'm going up towards, yep, positive infinity. Now, when you do your range, your numbers that you actually write in will have a bracket. That means that this number is included. So that -9 needs a bracket. Okay, my real zeros. I have 4 real zeros here. It looks like I have 3, but I have 4. So x equals what? What's my first zero that I see? -3, and then what? 1, but that 1 is that's with the dr. Double root, remember that? And it's a double root because it doesn't go all the way through the line. Because this 0 here does not go all the way through, that means it's touching it twice. It looks like it's just 1 time, but it's really 2. You could also just write 1 twice if you want. You don't have to write dr. But you have to show that you at least know that it's somebody twice. And then 4. So you could write this out if you like to do your coordinates. -3, 0, 1, 0, 1, 0, 4, 0. That 1 was a double root. All good? All right. Find the local maximums and the local minimums. Local maximums are the highs of the turns, and the local minimums are the lows of the turns. We talked about max and mins before, but this is when it's on a turn. Okay? So look at this first graph. I don't know what happened to our arrows. I just keep writing. Alright, so if I look to see where I'm turning here, and I'm turning there. Well, this one would be a max or a min. It would be a max because it's a high point, and this bad boy would be a min. So my local maximums and minimums, we always need a point, okay? My local maximum here looks like it is at -1, maybe +3. We're looking for that point. Where's that point? So my minimum looks like it's at what? 4, -7 maybe? That looks good. Alright, on my second graph, I'm across, or let's see here, here's a low point, high point, low point. My local maximum is where? What point is that? 1, 0. The local max is 1, 0. So your local minimum, I have 2 of them. What's the first one? -2, -9, and then what else?
Wait, that would be -9, right?
Yeah. -2, -9, and then we have 3, 4. Oh, -4. Thank you. +3, -4. Alright, I want you guys to type in this problem into your calculator. -x⁴, this one right here. -x⁴ plus x cubed plus 2x squared. And I want you to tell me how many local max and mins there are. Alright, so there should be how many turns? Sorry, there's how many max and mins. Your number of max and mins are the same as your number of turns. So if I know that my highest exponent is 4, 1 less is my turn, right? So there's how many local maximums? There's 3. There's 3 total, so there can't be 3 maximums.
Oh, I thought you.
There's what? So 2 maximum, so that means 1 minimum? Okay. Alright. Alright, let's look at increasing and decreasing intervals. Increasing and decreasing intervals are split by your max and min points. Basically your local max and min points. The word local just means that there are terms. So what I do first is I want to point out my max and my min. Here's the max, here's the min. So the max is where? -1, 3. And your minimum?
4, -7.
4, -7. Okay, so label on the graph where we are increasing and decreasing. I typically do this every time, and I want you guys to do it as well. I draw a dotted line right down wherever I change directions. Okay, once I draw my dotted line, I'm only looking at the x values. That's all we're looking at. So all the way to the left is negative infinity, all the way to the right is positive infinity. I'm first changing directions at -1, and then I'm changing directions at 4. I'm only looking at where my dotted lines are. Those will be the only important numbers for increasing and decreasing. Now we will have to ask ourselves what we're doing. From left to right, am I increasing or decreasing?
Increasing.
Increasing, and then we are decreasing, and then we are increasing. Alright, so we only need my bottom numbers. I'm increasing from negative infinity to -1. Remember that little union that means and? Little u. I'm also increasing from where? 4 to positive infinity. Good. You with me? I am decreasing from -1 to positive 4. Remember, for your increasing and decreasing, it is always your x values. And always parentheses. Always, always, always. We don't need brackets. Any questions here? Okay. Let's look at this practice. First, I'm going to put a dot on the max, on wherever I change direction. Is this off again? All right, give me a second. I want you guys to go ahead and put points and draw dotted lines where I change direction. Okay, so put my dots here. I'm changing directions at -2, 1, and 3. Let me move this one over just a little bit. Alright, so Carla, all the way over here is negative infinity, right? I'm changing directions at -2, positive 1, 3, and then I have positive infinity all the way over there. I'm then going to ask myself, what am I doing from left to right? I'm decreasing, increasing, decreasing, and increasing. All right, so my increasing intervals. I'm increasing from
-2,
-2 to 1 and
3 positive.
3 to positive infinity. Just matching it up with this. Increasing, I'm increasing. And then I'm decreasing from
Negative
and
1, 2.
1, 2, 3. Good. Important part there is to see where you're changing directions and then to look at your x values. All right, the second one, I am increasing the entire time. So I'm increasing from where?
-2.
Nope,
Oh,
because
yeah.
I'm
Negative.
not actually changing directions, right? So I'm increasing the whole time. I'm going up the entire time.
Alright.
It looks like it's on -2, but it's not. Am I decreasing at all? No. So you can write none. Any questions there? All right, here's the third part and final part. Once again, this is also nothing new. We've done it before. We can figure out the equation of the polynomial function by looking at the graph of the function. You need to find the zeros of the function. If a graph turns at the x-axis, this root is a repeated solution and should be counted twice. This means double root. That's what we just talked about. Double root is where it looks like it does not go through the line. It looks like it's just one solution, but it's two. All right, step 2 says change each x-intercept into a factor. That means if I have x equals +2, and I want to change it into a factor, that essentially means I'm moving this from one side to the other. So that means that I will have x minus 2. You take the opposite sign. It was a +2 when it was an x-intercept. When I make a factor, it becomes the opposite. You are then going to write the equation of the graph in y equals plus your factored form. Alright, you want to check whether your equation needs to be positive or negative. That's my last step. Alright, let's practice. For this one, it's asking, what are the zeros? Well, I'm going to look to see where I cross the x-axis. My zeros are what? What's the first one?
-1,
Okay, what's next?
2,
And then,
4.
yes. Okay, -1, 2, and 4. Notice how I did not just write numbers. You guys have to put x equals. So what are your factors? Well, what's the opposite of -1?
1,
+1. What's the opposite of +2?
-2,
So x minus 2. And what's the opposite of +4?
x minus 4.
X minus 4. When it says what is the equation, all you have to do is rewrite your factors and put them after your y equals. So I have x plus 1 times x minus 2 times x minus 4. Alright, this is the part that is new, because I didn't tell you this last time. When you decide whether it needs a negative or not, you're going to ask yourself, From left to right, am I going up or down?
That's right, come down.
You're going down, right? We decreased. So that means it should be a negative right there. If it's going down, then it is a negative. Any questions on that one? All right, let's look at these problems. On the first one, you can see here I have 3 zeros. So x equals to negative 2, x equals positive 1, and x equals positive 6. Okay? Your equation for this, I'm going to write it underneath, will be your factors. What's the factor for x minus 2? X plus 2. What's the factor for x equals 1? And the factor for x equals 6. Good. I'm going to put all of those in front of, or sorry, after my y equals. Now, Carla, from left to right, am I increasing or decreasing? You're increasing, so that sign can say positive. Okay? If we look at the second one, it looks like I'm only touching one time, but that is not true. I'm touching how many times?
2.
2. So I have x equals negative 4, x equals negative 4. It is a double root. Jordy, what is my factor for this? X plus 4. And we're going to do it twice. You can either write it twice or you can put squared. Either way works for me. The last thing, looks like I have 3, but I know that middle one is a double root. So I have x equals negative 3, x equals 1, x equals 1, x equals 4. All right, so we have y equals x plus 3, x minus 1 squared, and then x minus 4. And if I look at my graph, I am decreasing, so what do I need? I need a negative up front, because it's going down. Does that make sense? You all like remember some of this from earlier? Unit 1 and Unit 2? All right, so what we're going to do is let's turn to our homework. I want you to see this. Turn to homework BB. All right, so number 1 is negative 2x plus 5x to the 4 plus 3. They're asking you for the degree, your max terms, classified by terms, classified by degree, and then you have your end behaviors. The first one is left, the second one is right. Alright, so I want you to do what I'm doing up here. Is number 1 in standard form? No, so underneath it I want you to write 5x to the 4th minus 2x plus 3. Now it's in standard form. Get into a habit of doing that. My degree is my highest exponent. That will be what? 4. So So my max number of turns is minus 1. That would be 3. If I had to classify by terms, x to the 4th, classify by terms, I have 3 terms here. 1, 2, 3. Binomial, binomial, trinomial, polynomial. Trinomial. Classify by degree was x to the 4th. So x to the 1st is linear, x squared is quadratic, what did you say? Yeah, quartic. X to the 4th is quartic. This is what is new. I told you guys wrong last time. We are going to do the right in behavior first. Okay? We do the right in behavior first. So if I take a look, my highest exponent is 4. Is that even, Steven, or odd opposite? Even, Steven, so they're going to be the same in behaviors, okay? This 5 is positive, so I'm going to start with a positive. It's going up. Because it's even Stevens, I know the left is going to be what? It's also going to be positive infinity. Even Stevens means they're going to be the same. This should be the first row of your homework. Does this make sense? Okay. You guys have about 10 minutes to work on this before lunch, and then when you get back, we'll finish it, and I'll answer any questions.